Visualizations play a number of different roles in data science, and the role that they play changes how we'll handle the visualization. By the end of this video, you should be able to understand the different ways that data visualization is used in data science. There are two key ways to categorize data visualization. The first is whether this is conceptual or data-driven. Most of what we'll focus on this week and in this course is data-driven, but visualization of concepts is important as well, particularly when we aim to explain how things work conceptually. For example, economists may seek to visualize the notion of the classic supply and demand curve without using real data, and then back it up with data supporting the concept from, say, Uber surge pricing. Because data-driven is where we spend much of our time as data scientists, let's look at the second categorization in that context. Declarative. There's a point when we've analyzed the data and we have a data-supported conclusion we wish to articulate to our audience. At the point of presenting, we want our visualization to convey this conclusion to the observer in the most straightforward possible manner. Exploratory. We spend much of our time exploring data, and visualization plays a key role in that. Visualizations often encourage us and enable us to look deeper into the data. Let's take a look at some examples from these categories. So this is the classic supply-demand curve from economics that I just mentioned. It explains the relationship between supply, or the quantity of goods available, with demand, or the amount someone is willing to pay for the item. When quantity is low, demand is high. As quantity goes up, demand will decline. This is conceptual, and these lines are hypothetical. But since much of our work is going to be data-driven, let's focus on that for now. Here I'm taking a declarative example from a research paper of mine where we show that the peer instruction pedagogy resulted in a significant decrease in failure rates for students relative to standard instruction in computer science classes at UC San Diego. My goal in presenting these results was to convey to the reader the impact peer instruction had on failure rates in our classes. Without diving into the details too much, we had failure rates from a number of classes at UC San Diego where instructors either taught using the active learning pedagogy of peer instruction or using standard lecture style pedagogy. If you're interested, please read the full paper for a complete explanation of our experimental methods and possible limitations of these results. As good science will always detail potential limitations of results along with study methods, I hesitate to use the word declarative here, as it doesn't quite seem right. Rather, I prefer the term presenting. We knew the result that we had, and we were aiming to present it to the audience in a clear and useful manner. The example of the correlation between midterm and final exam scores from our previous video is likely explorative. I might create a plot like this when trying to better understand the relationship between these exam scores in my class, and its results would likely cause me to explore the data more. With explorative data visualizations, I'm not going to spend as much time polishing the appearance. So long as I can interpret it, that's fine. Likewise, I'll often want to be able to quickly plug in different parts of my dataset into the figure to explore different relationships, say homework scores against the final exam rather than midterm against the final exam. Exploration is really at the heart of the data science process, which we talked about in week 1. When we're finding outliers or trends, we're often using visualization tools. And those visualizations lead us to dig deeper into the data. As we dig deeper, we do the same thing, looking at data distributions using histograms, exploring relationships between variables, or seeking other trends. Ultimately, we find ourselves zooming in and out of various parts of the dataset as we try to gain a better understanding. And this process of zooming in and out of the data is almost always accompanied by and facilitated by data visualization. So now that we understand the different uses for data-driven visualization, let's explore metrics of success for those visualizations.